Okay, for this day, we're going to talk about dependent events, and then we're going to talk about independent events. Dependent events are when the outcome of one event influences the outcome of another event. Okay, and then there's a rule that we basically use for that. If we want to find the probability that these are both happening, if they're dependent, we have to take the probability of the individual event times the probability of the second event happening, or the first event happening, given that the second event has already happened. Okay, so it makes more sense when we look at examples. It says about 55% of high school students participate in a school athletic team at some level. Roughly 5% of high school athletes go on to play on a college team in the MCLA. What percent of high school students play a sport in high school and, so that's the intersection, go on to play on an MCLA team? So if we call this high school and we call this N for NCAA, we're wanting to find out what is the probability that we're doing both. So we need to do the probability of high school times the probability of NCAA, given that they played high school. So they give us these two, so we got 0.55 times 0.05. We're going to multiply those two together and get 0.0275. Okay, here in the next example, it says Helen plays basketball. For 3 free throws, she makes the shot 75% of the time. Helen must now attempt 2 free throws. C is the event that Helen makes the first shot. So the probability of that is 0.75. And then D is the event that Helen makes the second shot. The probability that Helen makes the second free throw, given that she makes the first, is 0.85. So we are multiplying the 0.75 times the 0.85. So 0.6375. Okay, example 3 is a little bit more complicated. It says the community swim team has 150 members, so this is our total. 75 of the members are advanced, 47 are intermediate, and the remainder are novice. The novice is like beginner. Okay, 40 of the advanced swimmers practice 4 times a week, 30 of the intermediate swimmers practice 4 times a week, 10 of the novice swimmers practice 4 times a week. Suppose one member of the swim team is chosen randomly. What is the probability that the member is a novice swimmer? So if we go through our stuff here, we know the total is 150. So we have 75 that are advanced, we have 47 that are intermediate, and we don't know our novice number, but we know they have to add up to 150. So I have to figure out what would make my total be 150. So if I add up what I know and take it away from 150, I'll figure out that my answer is 28. So 28 out of the 150 is going to simplify to 0.187. B, what is the probability that the member practices 4 times a week? So 4 times a week, we said up here we had 40, 30, and 10 practice 4 times a week, and that's out of 150. So if I add up all those numbers, that's 80 out of 150. And if I calculate 80 divided by 150, we're going to be at 0.533. What is the probability that the member is an advanced swimmer and practices 4 times a week? So advanced, if we look up here, advanced was 75. Oh, wait, sorry. Advanced, it was 40. I'm sorry. Advanced was 40. there's 150 members. So 40 out of the 150, which is 0.267. And then the last question, what is the probability that a member is an advanced swimmer and an intermediate swimmer? They can't be both things. They can't be advanced and intermediate, so that's just 0. Okay, you can't be both advanced and intermediate.